We have a panel of distinguished participants, and there's, I think, two sets of issues here in this discussion. If we take the charge literally, which is the announced topic in the agenda, it is the science of CyberGIS, implying the theory, the principles, the knowledge that constitutes CyberGIS itself. But there's also, of course, the interpretation of the science with CyberGIS. And so I thought that perhaps some of the panelists might like to take that perspective rather than the first. So in putting together 7 questions, I've tried to mix the two interpretations. So the first 4 are essentially the science of CyberGIS, and then the last 3 are essentially science with CyberGIS. So what I've proposed is that we follow the same strategy as yesterday for the panel, which is to ask each of the 7 panelists to comment just initially on some of these questions, on their choice of these questions or any other questions they think are relevant, and then we'll open it up to general discussion in the panel. Dawn did remind me yesterday that in the early days of the science of GIS, there was a paper published in the Annals, with Dawn's name on it, and mine, on whether GIS was tool or science. And there was some correspondence later on that topic. So perhaps that's an analog of the situation we face today. We could ask the question, is CyberGIS tool or science? And if it's tool, then questions 5 through 7 would be the most relevant. If it's science, then questions 1 through 4 become relevant. So I think that's one of the issues that perhaps we can get a sense of in this discussion, and that might guide the future development of this field. So I don't think we really need to introduce anybody on the panel. Everybody's been here on and off for the last little while. But maybe we could start with Dan and go from my left to my right, your right to your left, across the panel, and just ask everyone for some initial thoughts, and then we'll open it up for a general discussion.
Obviously, I picked the wrong location. I thought you were going to start from the other end. Okay. I have a couple of points to make. I think for the first round, I will share some of my preliminary thoughts, and then I will maybe during the second round to go back to the questions, to your 7 questions. This is my first of all. I want to congratulate Xiaowen and the CyberGIS project team for all the remarkable achievements you guys have accomplished during the past few years. I was a part of the Washington D.C. CyberGIS workshop 2 years ago, and I have been following the progress this project team has been made. I'm really very inspired. I use some of the material in my GIS courses at a various level. So. And also I have learned a lot during the past 2 days. But here's my quick observation. I have several points, but I will try to make it as succinct as possible. So before I came here, I just finished the book chapter for STAN open source updated version geocomputation. My chapter was on ubiquitous computing. So my first observation, while I was sitting in the audience hearing all the presentations, that I was a bit surprised that the ubiquitous computing was not even mentioned, by most of the speakers, which is obviously another sort of major trend in the computing business. It's all started with one of the Mark Weiser's classic paper published in 1991, while he was speculating the computers the paper was published in the Scientific American. It was entitled Computers in the 21st Century. I think there's a very memorable line in that paper. He was speculating that the most profound technologies are those that disappear, that they wave themselves into seamlessly into everyday life, fade into the background. That's his prediction. Although after this afternoon's tour of the supercomputer, we also see at the other end, that's the supercomputing facilities at the petascale, at the server level. But at the front end, it's becoming smaller and smaller. It's embedded in everything else that we use these days, from your kitchen appliances to your cars to cell phones to your cardiac pacemaker, everything implantable, from inside our human body to the wearable computing on the earpieces, belt, clothing, all the way to smart planet. So that's, I think the CyberGIS should be more closely tied to the growing literature of ubiquitous computing, because ube in original Latin means everywhere, so by implication it's spatial, it's geographical, and there are a couple of research questions we could pose in that context related to sensor network, related to the Internet of Things, and also I didn't see here a whole lot of discussion on to addressing the issue, the so-called GIS. As we know it so far, is pretty much a 15% technology. By that, I guess John Wilson meant that humans, if we are thinking about ubiquitous computing, the idea was to put humans back into the center, not computing or the tools we use. But humans spend 85 to 90%, depending on the literature you are following, inside buildings. We spend at the maximum only 15% outside doors. But the technologies we developed, all the applications we developed so far, focusing pretty much exclusively on human activities outside the building. So I think one sort of direction we could pursue is really to make a CyberGIS by tying it closely to ubiquitous computing. That's really to address the other 85% of human activities. It could be related to health. I know Sarah could also have a lot of indoor air quality, all different sorts of things. So that's one thing. And related to theory, I was really intrigued by the emerging literature called, there are different names have been labeled to it, ecological computing or nature-inspired computing. In today's talk, I was it's really gratifying that I saw the term ecosystems, to create it from a software ecosystem or a digital infrastructure ecosystem, to think in terms of ecological terms. So I think that's could be a new sort of theoretical guidance for us to think about, to design, the new cyber infrastructure in the context of CyberGIS. I think I have several other points. I think I will shut up here for now.
Sure, thank you. One.
This is my first time to ask to be in a panel. I'm so honored. Thank you so much, Mike. I would like to share some of my thoughts for the second question. In what ways my research can contribute to the science of CyberGIS. And over the past 2 and 3 days, I have been watching so many wonderful presentations, and a lot of them try to address the computational science aspect of the CyberGIS, and by using the high-end computing facilities. And my research interests are focusing on to address the data science aspect of CyberGIS. And over the past few years, I have been working on increasing the accessibility of geospatial data, especially the accessibility of big geospatial data. And I like to share 3 examples to identify the gaps in current research, and also to emphasize the importance of data discovery in our research. So the first one is on the first day, I remember to go through the CyberGIS gateway, and when I follow the tutorial, I see when I want to do a wheeled shed analysis, there are 3 data sets provided by me. One of them is like the 10-meter NED DEM data. And if the CyberGIS system is able to provide higher resolution data, like, for example, the Maricopa County of Arizona has provided the 1 feet of DEM data available. If we can make that available to the end users, it will help them to generate more accurate result for wheeled shed analysis. And the second example I want to share with you is in the climate studies, like the scientists nowadays are very tend to use statistical models to study the formation and to predict how the hurricane, like tropical storms in the Gulf of Mexico area will be developed. However, even if we use the best model but less satisfying data, the accuracy of the result may be not very satisfying, and the prediction error will be increased. So the third example I want to share with you is from the recent conversation with my colleagues at UCSB. And a professor came to me saying that he wants to study the urban footprint of the fire stations, and he wants to find all the locations of the fire stations in Los Angeles County. But however, once he went to the website of the fire department, the information provided there has a lot of missing data, and he asked me whether I can use my cyber approach to help him to locate all the fire stations for his study. And through these 3 examples, we can see the importance of data search in the CyberGIS research. And currently, so many data are available through the Web 1.0, like the general web pages, or Web 2.0, the social networks, or different geospatial databases. So the incorporation of geographic information retrieval and spatial data mining could enable the automatic retrieval of the spatial data. And my second research interest is in spatial semantic interoperability, to make the different GIS systems understand each other, and to make the data exchangeable through the different systems, and to make the analytical tools chainable to answer complex scientific questions. And the motivation and ultimate goal is to answer the question like the example given in Max keynote speech. Like, for example, if I want to know all the populated places with a population more than 100,000 near Mississippi River, intelligent CyberGIS should be able to understand the place name and other naming entities and the spatial relationships, and could be able to combine the semantic reasoning and the spatial reasoning to answer these complex scientific questions. And my third research interest in data documentation and data cataloging, as Dr. Ansley and Dr. Grichard all mentioned the importance of spatial metadata. And OGC, the Open Geospatial Consortium, has provided the catalog service for the web to enable the storage, indexing, and the discovery of geospatial metadata. However, the current information model only support the registration of data and services. It will be a great addition if we can extend the current information model to make it a knowledge catalog as well, so the different catalogs can freely exchange the knowledge and the conceptualization for their database. So these are the 3 research area that I'm very interested in and have been working for the past few years. I hope it can make contributions to the data science part of the CyberGIS and the GIS science at large. Thank you.
Thank you. Sarah.
I was just invited to this panel about 10 minutes ago, so please, I apologize for my comments if they seem a little bit incoherent. Anyway, I definitely cannot speak to the science of CyberGIS, though I would be very, very interested in, some good, quick one-liners about that, because people in my department and school and college always ask me, well, or always say, well, it's just a tool, and, you know, to be able to explain the science of it in a few short sentences would be great. So if anyone has ideas on that, I'd really appreciate it. But I am very interested in science with CyberGIS, and actually about 2 weeks ago we had a small workshop between the AAG and NIH on CyberGIS in health research. So, and really trying to explore the possibilities of bringing in CyberGIS to sort of mainstream NIH health research. And it was a great workshop. Xiaowen was there and did a nice job convincing people of the value of CyberGIS. And we also had some good examples of areas where health researchers are using huge space-time data sets, especially with these sort of sensing systems, personal monitoring systems. And it seems to me, based on the presentations I've heard here, that there are tremendous opportunities for bringing CyberGIS into health research. However, I think that there is a big gap between what's going on in CyberGIS and what the typical health researcher does. And we need some sort of a translation process or a process to bring those communities together. And doing that is, I think there are a couple of things that would be helpful. Well, first of all, we need sort of multidisciplinary teams, which I know people like Xiaowen are starting to develop, and we need more of them that include both CyberGIS people, maybe people who understand health research, but also can kind of provide a middle ground, and then also mainstream health researchers working together on teams. Another thing that's needed is, an effort to understand different sort of epistemologies. I mean, when you talk to health researchers, a lot of them are very wedded to things like case control studies and individual level health studies. And we really need to kind of demonstrate the relevancy to them of, these big environmental data sets, sensing data sets. They don't necessarily understand those things off the bat and don't necessarily see the value to them. So again, thinking about different ways of knowing is really important. And then finally, it would be great if we could have some really compelling examples to show how, using these big data sets leads to interesting and novel findings. And I know that's going to take time, but just having a few good case studies that we can pull up and show to people, that would go a tremendous way to bridging that gap. So I want to thank everyone who's at the conference. I mean, I'm so impressed with the work that's going on, and I really hope that it will, over the next 5 to 10 years, really feed into the health research community. Thank you.
Thank you. Dawn.
Well, I think I'll start off with just a few thoughts about the tool versus science situation, because when I mentioned that at lunch today to Mike, it was really a joke because it was really from the perspective of I was hoping that we would not have to actually revisit the tool versus science debate, because when Mike and Jim Proctor and myself were thinking through that in the late 1990s, and I was a graduate student at the time, that was a different time, a different culture. And one of the things that we concluded from the paper in the paper that we published at the time was that these kinds of debates need to be thought of in the context of the trends in science and society at that time. So at this time, we are now in the fourth paradigm, where the technological issues, these research emphases are respected and embraced. And I was thinking about even the word informatics. I haven't heard the word informatics at this meeting, but I think it's very closely allied to CyberGIS and what we are pursuing here. There's health informatics, there's bioinformatics, eco-informatics, ocean informatics, and I think that's recognized as the science of information, the science of information processing. We've heard a lot of wonderful talks about dealing with Twitter and Wikipedia and the social media information. So I'm hoping that we're actually not going to have to fight that battle again about what is the science of CyberGIS, what is the science with CyberGIS. With that in mind, I thought I would just take a few seconds to respond to questions 6 and 7, and I think I've already responded a little bit to question 6 in terms of the best fields for us to be promoting CyberGIS. These are fields that are already thinking about these broader information issues. They are already dealing with big data, or they're realizing that big data could overtake them, and they're looking for ways to handle that so that they can interpret, find meaning in their data and in allied data. These are already largely interdisciplinary fields. So again, I'm talking about health research, ecology, biology, oceanography. Conservation biology covers those areas quite well. Climate science, of course, and sustainability science, I think, is really key. And so I missed the discussion on Monday, I believe, about sustainability information science, but I think that's going to be a really fruitful area. This is particularly, and we're talking about cultures here, academic cultures, and they're gatekeepers, so to speak, to acceptance within these cultures. And so I was thinking about the proceedings of the National Academy of Sciences, for instance, and the National Academy, where they have actually made the case already for a sustainability science, where you're taking the various environmental sciences and you are trying to understand how the earth works, earth processes, but the human element is also incredibly important, and you're using that science to actually solve societal problems. You are using science to help eradicate disease and poverty. And again, this is another area where CyberGIS can be squarely in the middle. So I'm very happy to hear these discussions about sustainability, sustainable cities, and so forth. In terms of, I wanted to speak quite passionately to the 7th question, because this is a missionary task. Mike referred to the missionaries of archaeology and history and health science in terms of promoting GIS in those fields in the early 1990s and beyond. I really think that it will continue to take these singular missionaries or small groups of people to go into these allied fields to promote CyberGIS. So this means going to their meetings, having specialist meetings where these people are invited. So it's a two-way street. We go to their meetings, they come to our meetings. We already have that here at CyberGIS'12. It means publishing in the literature, in our literature, to expose our colleagues to CyberGIS as applied in these areas. So the use case example is, I think, extremely important. It involves publishing in their literature, so we do have to have some street cred, if you will. We need to have some background in those sciences in order to play nicely in their playgrounds. And then it also means training our students to have this perspective where they are thinking broadly about CyberGIS in many different areas. So we have our own students, of course, but Many of us who teach courses where we are seeing students from across the university campus from different disciplines. That is our chance to promote CyberGIS to these allied fields. So this sort of spreading the gospel missionary, and for those who are not religious, I apologize, but that's what's coming to my head at this time in the afternoon. I think that's going to be extremely important.
All right, thank you. Mike?
I'll be a little shorter. I'm glad Don brought up the issue of whether we're going to discuss science versus tools again. It's one of the things that I was thinking about when I read the questions. I was wondering, we could obviate this discussion altogether if we would have called the term, instead of CyberGIS, called it CyberGIS science. And I don't know who came up with that, but perhaps that would obviate the discussion. I tend to fall, as I mentioned earlier, I tend to have worked more with federal agencies and less with NSF over the last few years. And relevance and so what, as Lynn asked the question earlier today, is always on the mind of federal agencies. And I tend to point my students towards 4 terms. I said, are you creating new knowledge in your hypotheses? And I think if we're creating new knowledge, it's probably to a domain area, something like computer science, probably GI science. My human geography colleagues probably wouldn't agree that we're creating new knowledge, but we're certainly enabling the creation of new knowledge by the application of CyberGIS. I think that's kind of the holy grail. We can always ask ourselves that question if we're creating new knowledge on processes. And if we're not, I'll go back to my history with NASA, as things are always faster, better, or cheaper. And if they were one of those, then there was relevance. And if they weren't faster, better, cheaper, creating new knowledge, then what are you doing? The question number 4 on how you can promote the inclusion of CyberGIS into curricula, I think that's an intriguing question based upon a little bit of the discussion yesterday. And I think back on when Dwayne Marble was involved in the body of knowledge, he was arguing that we actually adopt the computer science model of the scale from awareness to mastery in any specific subject area. I like that. It made a lot of sense. I could fit topics into my courses based upon whether I wanted my students to be just aware of something like CyberGIS, or maybe they would have skills, or maybe they would be a master in it. And I think that's the question we have to ask ourselves, how we fit that into our courses. But let me step back and say that yesterday there was a comment brought up that maybe CyberGIS should sort of disappear into the cloud. Okay? And if we want that to happen, then should we even be teaching CyberGIS in our courses? It should disappear. And I would argue that just like we use global positioning system receivers, we use cell phones, but how many of us know whether there's a GPS receiver, whether there's a cell trilateration receiver in there? We don't know. But you never know until it breaks, until it doesn't work. You walk inside a building, you don't get a valid fix, you're using a GPS receiver. Okay? And the cell trilateration would be able to determine the position. So in certain circles, you need to know how things work. And if those circles require you to know how that infrastructure works, how the computing works, and I think then it's got to be in your classroom. So.
Great, thank you.
I hope that's going to work. Well, in fact, to follow on from Mike there, one of the facts that I learnt this afternoon is that 1% of the time on the new petascale facility will go to under 18s. That's 3.65 days every year. Now, when I was brought up in Northern England in the early 1960s, to have that sort of thing would be like being allowed to drive a railway train, or perhaps behind a racing car. Which led me to think about the position of the CyberGIS and the curriculum. And I think that listening to the discussions over the last 3 days, I've learned a great deal in terms of my own understanding of CyberGIS. Some is very, very new. Some is quite disturbing. Some is actually really rather familiar, and there's 1 or 2 things that I think ought to be in there that we ought not to forget the experience of the last 30 years in terms of GIS and the curriculum, and GIS in relation to other domains. And in a previous life, before I had the luxury of 8 years without any teaching whatsoever, and those of you who do teaching will regard me as being remarkably lucky in that regard. One of the things that made my job as a lecturer at Newcastle very, very easy was the existence of the core curriculum, which came out of the National Centre for Geographic Information and Analysis, which I used to teach to undergraduate geographers and undergraduate planners. And the body of lessons in there was well organized, and it saved me from a great deal of thinking, and also I learned a great deal about GIS from it myself. One of the things that comes out of that is I think that CyberGIS in the curriculum, or where it goes into the curriculum, should be inclusive rather than exclusive. And that goes back to the 1% of computer time for the under 18s. In an experiment we ran in Ireland a few years ago, we discovered that you could teach the workings of the, and I hope Steve Coop will forgive me here, of the interface of ArcGIS was easily picked up by 15-year-olds. And I witnessed a marvelous demonstration of 3 15-year-olds to very senior educators, not just in universities, but from the Ministry of Education in Ireland a few years ago, as to their ability to use GIS and to answer questions with GIS. If they can do it, I'm sure they can do it with CyberGIS. The one other area does worry me slightly, and that's because I lay claim to being a social scientist, and the computer scientists among you are going to groan and say, oh God, he's going to start waving his hands around in the air. One of the debates which has been very polarized, certainly in Europe, has been between the social sciences and their view of the position and activities that go under the heading of GIS. And I think it would be unfortunate if what I've seen over the last few days in terms of the fantastic enthusiasm of people much younger than myself, the amazing levels of expertise and the amazing levels of industry should be misguided by perhaps inexperience. One of the areas which we do as scientists is to make sure, I think, that we do good science. I won't single out anybody, but one of the maps I've shown, and I think it's been shown twice, appears to suggest that nobody in Portugal talks about armed conflict. Well, I'm sure a race that conquered, that explored a great deal of the world back in previous centuries probably had a great deal to do with armed conflict, but maybe they spoke Portuguese in doing it, and that we shouldn't forget that maybe CyberGIS is not just the province of the Anglophones or those with the ability to speak English, and that there are there are other ways of looking at that. And I think just finally, one of the areas which I work in, and if I'd seen some of the computing equipment over the last that I've seen over the last few days, would have made some of the work that we're doing at the moment at the NCG in terms of the rather clunky inferential framework for geographically weighted regression. I have a colleague who's sitting in front of a workstation for the next 5 weeks running simulations in R. If I had a petascale machine, then that 5 weeks would go down into about 5 minutes. Is that, again, that there's a great deal of experience and expertise in other domains, particularly statistics and spatial statistics, which can inform the work that we do under the umbrella of CyberGIS. And again, my plea is for CyberGIS to be inclusive rather than exclusive in that regard.
Thank you. Hal?
Thank you, Mr. Chairman. I'm Harold Mollering from Ohio State University, have been involved in analytical cartography and GI science since the early 70s. And what I'd like to do is try to give a general perspective to this, and I think one way to do this is to look at this kind of question, or this set of questions, and start at the general level and maybe begin to work down to the more specific things as the discussion on the panel progresses. But if we look at things from the philosophy of science point of view, what defines a science is it had its own individual body of theory and body of knowledge. And if we talk about CyberGIS and where that stands, is that a science? Well, you can look at the unified body of scientific knowledge in general, and how you carve that up into various disciplines is somewhat arbitrary. And if you look at various universities, it's done differently in different universities in some areas because it's arbitrarily convenient, normally administratively convenient. If we look more at the theory part, Waldo Tobler, who was a great god of analytical cartography, used to talk about the half-life of theory versus the half-life of technique. And his point was that if you're going to offer courses in the university, your courses should focus mostly on the theory, because that has a half-life of maybe 15, 20 years, something like that. But oh yes, you need the technique because you're going to offer laboratory sessions and things where the students can take this knowledge they're learning and actually utilize it and implement it through various kinds of exercises in laboratories. And there he said that the half-life is maybe 3-4 years. Now these numbers in years are arbitrary, but you get the point. And his point was that you should, in a university course you're offering, you should focus more on the theory and less on the technique, because the theory will stick with people more. Well, when you look at the question about GI science, CyberGIS, cyber infrastructure, you could potentially raise the question, well, is that a science or a technique? And it depends on the perspective, because somebody in GI science may look at cyber infrastructure as a wonderful tool to be able to do something now with our theory. But if we put these things together in some of the system examples we've seen during this meeting, the person who you're trying to reach to use this will see that as this resulting system as a tool they can use. So whether something is a tool or whether it's a science, a lot of that depends on the perspective of where this individual is in this kind of process. And so that all of these things are some of both. And really what happens, I think, is that these things reinforce each other. The tool theory question, those things reinforce each other. And every area you can think about is some of both. And so that when we get with debating this of whether something is one or the other, that's not really very productive, but it's some of both. And when really where you get the productivity out of this and the usefulness out of this is when you combine these things together so they can reinforce each other. And I think this is, if you look at what's been going on here and the really interesting examples and the powerful examples that have been presented, it's really a skillful combination of both of these things together. The cyber infrastructure and the GI science. And you can go off to a place in a pub somewhere and then debate about what's science and what's tools. And in the quanta from my seminars in the university, that's a 3-pitcher question. Thank you.
Thank you, Hal. So it's time for the audience. We've heard from each of the panelists, but we'd like to hear the reactions of the audience or any comments or any questions. And then before we finish, I'll come back to the panel because I know Dan, for example, has more things he'd like to say. So who would like the microphone? Dan.
I would be interested in hearing the panel members say something about next steps. If there is a belief that there is something to be gained by forming more of what I call a knowledge community, hopefully using some of the technology to facilitate the formation and activities of that community, what would be some specific next steps over the coming year towards that goal?
Who would like to, Dan?
Yeah, I think one of the things that we could do, I had a brief discussion with Luke during the recent Mapping Science Committee meeting, was to really invest more in our educational efforts of GIS courses, GIS science education at an undergraduate and graduate level, because the technology has changed dramatically, in terms of what we should teach and how should we teach GIS stuff. We needed to start the conversation and develop new educational materials. I recall Lynn mentioned that nowadays if you type in CyberGIS in Google, the first 5 or 25 pages are all Chauvin's stuff. But also I did the Google Inside search, CyberGIS. Google track down all the keywords, to see the spatial, temporal, who are interested in the stuff. To my surprise, it's not appeared yet. So Google Insight told me CyberGIS, the keyword search, does not have enough search volume to warrant a graph showing the trend, the temporal trend. So that tells me that perhaps even we have a little bit of propaganda or marketing work to do to for the CyberGIS to reach broader audience. And related to that, I don't know whether you guys paid attention to a very controversial killer app on smartphone called Girls Around Me. The technology behind it is really CyberGIS, but that application caused lots of attention in the media, in the the law enforcement, all different sort of things. But the guy who developed that technology is linked the social media, locational data, plus some of the geospatial. So it's really cool. But because of the public pressure, the developer of that iStore has pulled. The recent news was that they have to take out of they pulled from the iStore, as a application.
Yeah. Anyone else on next steps? Dawn.
I just have the feeling that we're still at the very first step. I feel as though this NSF-funded project needs to run through to its completion. I think it's extremely impressive and inspiring that halfway through this grant, we're having a conference like this with results that are already being presented. And so, wow. Let's see this through to its completion and see where we are there. And there's so many things that we have to build. Many of the presentations all talked about the next steps. So we need to finish coding here, and we need to bring in more users there, and we need to deal with these issues with the data and the user interface and so forth. And in terms of knowledge communities, we have to build those communities. Even something as straightforward as the CyberGIS gateway, or some of the resources that we are trying to build at Esri. They've just now come online, and we have so much content to put into those knowledge communities. We have so many people to bring in to them. So a lot of promotion, as Dan has mentioned, a lot of work to be done there.
Okay, Mike.
Well, I've said this just a few minutes ago in my presentation, that I think the barriers to entry are still a little high for the large number of GI scientists anyway. And so by lowering the barriers to entry, I think you could open up the interest among a large numbers of spatially aware people or scientists. And I hate to use the analogy that I'm thinking of, but I will anyway. I mean, when Google released Google Maps and Google Earth, I mean, there were so many new ways of doing things that they wouldn't even have thought about. And they enabled individuals to be creative just by making it available and to the extent that they did and made it free. I mean, you can think about our cell phones. Well, what if our cell phones weren't location enabled? We geographers wouldn't have much to do with them, would we? So I think those two technologies, the fact that they provided the platform for people to be creative, people that may not have the resources to be creative in and of themselves, I think by lowering those barriers to entry, at least for high performance computing, could make we'd be surprised, as Mike Finn said the other day when we were talking about the big killer app. You know, sometimes you just don't know you're creating the big killer app.
Okay. James.
One of the things I've encountered when I talk to companies that collect private data about individuals is they sometimes feel they're on a ticking time bomb in many ways, because for the first time we have a huge amount of information about individual people, and actually we've got the computational capacity, and we're promoting that capacity to actually do the analysis at the individual level. A large reason for aggregation is because it makes your data set smaller. So I was just wondering if the panel thinks we're going to hit an ethical limit at some point where we start doing the analysis on the individual level, and we'll find that there's some kind of backlash because many of the providers of the data are not necessarily aware of the extent to which they're providing data through their cell phones or locations on Twitter.
I think that's already a huge issue. I mean, definitely in the health field, you cannot get individual level health data, you know, the sort of data that you would want to use. And with cell phone tracking and stuff like that, I think you're absolutely right. As the resolution gets higher and higher, and that we may hit some sort of barrier in that area. And I think that should be one of the research agenda subjects for this community and others.
Martin.
Okay, the area of the individual data. I've worked with individual health data. Some of you in the audience may be aware of the geographical analysis machine, which is the product of Stan Openshaw, in which he attempted to look for the existence of anomalies in the prevalence of cancer in northern England. The data were for individuals, and we had no network machines in those days, so it was all on floppy disk, but held on trusted machines. The actual analysis was aggregated to the equivalent of zip codes. So in that sense, it was analysis. More recently, I've dealt with individual data and had to become a temporary employee of the Census Office in Ireland. And I've also, we have a project dealing with individual death records in Ireland. Again, that's held on a trusted machine that's not networked and is in a secure room. It's doubly encrypted, and but that allows us to undertake the analysis. So there are, and both those projects had to receive ethical approval. So there are ways. So as long as we are aware of ethics, and it goes back to the my sort of points about doing good science, is aware of the ethics of science as well, and learning from other disciplines shouldn't disbar us, I think, from pushing the boundaries forward in terms of analysis.
Mm-hmm. Okay, Mike.
So just to comment too, I found it interesting that it's becoming a little bit generational. And when we were having this conversation with a young person working with me, she said, well, you know, we grew up with this technology and we're used to it, and we sort of don't expect or feel a need for the privacy that you old folks do. So, you know, maybe they just haven't matured to worry about it. but at the same time, they're comfortable knowing that some of their data is out there that can be harvested. And I don't want to say it's a generalization, but I have heard that kind of comments from some younger folks.
Yeah.
Mike?
Yes.
Just one comment on that sort of thing in terms of personal privacy. Many of these things we're talking about, Twitter and Facebook and all of these sorts of things, are relatively new and novel technologies. They're rather immature. And my guess is the general public doesn't realize that a lot of this information is being collected on them. And it wouldn't surprise me at all if at some point there's some cases of stalking or something like that that comes into the public domain, and then there'll be some kind of concern about privacy limits on that. Mm-hmm. It's my understanding that in Europe, and perhaps some of my other colleagues here can say more about that, in some of the countries in Europe they're considering this, are examining this sort of question now. In the US right now it's more or less an open book. Mm-hmm. But one would guess it's the novelty and the immaturity of this technology that so far it's just open. But it may well be as things develop that the privacy question will become of more concern. Thank you.
Mm-hmm. Okay. Anyone else? Microphone is open. Jake.
Right. You're exactly right about the ethics. Yeah. I should have said that. I forgot.
Just a comment mostly, and that is that I've heard several references today in various forms to the non-GIS expert and the non-GIS user, and just simplifying the end user experience, which I do think is important for 5, 6, and 7 in terms of reaching out to other domains. But I do want to urge some caution in simplifying the notion of the non-GIS expert, and suggest that there is a continuum of expertise that people will demand from this community. And there is this continuum of empowerment that they're going to look for in terms of access to concepts, tools, and data, and so forth. And so it's more a comment to not simplify the GIS non-expert, because I think 5, 6, and 7 will be successful if we understand that that is nuanced.
Yeah.
Mm-hmm. Thanks.
Thank you. Anyone else? We're reaching the point for the opportunity for the last word from the audience. Okay. Well, then let me come back to the panel and ask if anyone on the panel would like to add anything or like to have the last word. Dawn.
I don't usually volunteer for the last word, but but I wanted to respond to the comment that you just made. I think it is so important, and I was having a conversation with some academic colleagues about the whole idea of the easy interface, and even the era that Google Earth has ushered in, where the geo browser is so familiar, and even with regard to GIS, some of the technologies that Esri has produced, you can make some horrific maps with these technologies. And we were talking about the need for cartographic education, cartographic principles. These are still so very important, because the other side of this is the misuse of the technology, the misinterpretation of the science with these technologies. So I really agree with that, and I'm very glad that you brought that issue up, because I think it is extremely nuanced, and we have to be aware of that.
Dan?
Thank you, Don. I think I was really intrigued by sitting in the audience listening to the various talks during the past 2 days. I heard quite a few very intriguing buzzwords, starting from Chauvin's synthesis to Don's map stories. My colleague Ola talked about games. But those buzzwords remind me, my cognitive science friends told me the buzzwords are appealing more to the right side of the brain. So I want to expand our left side brain is more on analysis, the simple arguments. And so I would like to expand that a little bit to tie it to CyberGIS. That there are two other sort of elements that are related to our right side of the brain is about design. And so far, based on the CyberGIS applications or development, as far as its development is concerned, I see there are great potential for CyberGIS applications related to geodesign. And we started the workshop in 2008, and ESR has been hosting Geodesign Summit during the past. I think we are going to doing another one in January, right? Yeah. It's really gaining momentum because it's about, instead of focusing cartographic modeling, asking the question of what is, a descriptive question, and asking the question why. Geodesign tools really enable users to imagine new things that doesn't exist, then ask why not. So I think if we can equip the CyberGIS with some new design capabilities, then we could make the tool be appealing to a new set of audience, urban planners, landscape architects, and the whole series of industrial designers as well. And as far as application is concerned, I want to mention that GIS has a military origin. It's still being used on a daily basis in the most sophisticated drones to guide all these most sophisticated weapons to kill people. But don't forget that GIS or CyberGIS could be potentially used to monitor the global human rights abuses. I'm currently on the AAAS Geospatial Technology in the Human Rights Abuse Project Advisory Committee. By working on that committee, I learned that we could, if I could pick one application domain that could really help the cause of promoting CyberGIS, I would say let's find some good case studies of using CyberGIS for global human rights abuses, because that would counter all these military applications to promote apathy. Because when people are apathetic about the tools or the science you're doing, you will most likely to attain more followers.
Mm-hmm. Good, thank you.
Good last word.
It is. It's a good last word. I agree. Okay. So I think with that, let's declare the session over and thank all the panelists very much.